Good morning, everybody. So, in the previous lecture, we have discussed about rapidly varied flow, and in that rapidly varied flow, also, like in gradually varied flow, what are the assumptions and what is the general equation for rapidly varied flow? The general equation for rapidly varied flow is nothing but the equation of hydraulic jump. The equation of hydraulic jump. So that general equation for hydraulic jump or rapidly varied flow is given by Q square by GA1 plus A1 Z1 bar is equal to Q square by GA2 plus A2 Z2 bar. This Q square by GA plus AZ bar is called as specific force. So that's where yesterday we talked. But this general equation is only useful for derivation purpose. But for solving the problems, we know what is the shape of the section, and accordingly, we need to apply that equation to that shape and get the solution. So, naturally, here also, normally, wherever we are having a formation of hydraulic jump, generally there it will be a rectangular section. So, assuming that it is a rectangular section, we will see how to apply it for a rectangular section and which is useful for us to solve some of the problems. So that is what the topic today is. So the same the rapidly varied flow equation or hydraulic jump equation, which is derived for a general case, now we apply it for a specific case of rectangular channel and see what we will get. And this is very, 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 very important for you to solve any problem in hydraulic jump. So let me take over to that actually. So today's lecture mainly focuses at hydraulic jump in rectangular channels. Your question may be, sir, rectangular channels only you are doing, is it not for trapezoidal channel? Only thing is the complexity of the problem increases. So at the undergraduate level, we are only taking up hydraulic jump in rectangular channels only. Whether it is hydraulic jump or basically for gradually varied flow, we do only for this as far as undergraduate course is concerned. The moment we go and land up into the post-graduation course, then naturally the other trapezoidal section also we will do it. This is basic the thing. So now you know the general equation for hydraulic jump is in any channel is q square by GA1 plus A1 Z1 bar is equal to q square by GA2 plus A2 Z2 bar. This is the general equation. So for this general equation, applying it for rectangular channel, applying it to for rectangular channel. Now you take it A1 is equal to BY1, right? Z1 bar is nothing but Y1 by 2. Similarly, A2 is equal to BY2 and Z2 bar is nothing but actually Y2 by 2. So now if I apply it the same thing actually, and one more point also you can remember, Q by B is equal to small q, or Q is equal to small q into B. So I will use these equations. So if I use it, actually what I will get, the q square, I can write it as small q square b square divided by g into by1. This is a1 plus a1 is by1 into z1 bar is y1 by 2 is equal to q square b square by g into by2 plus a2 is by2 into y2 by 2, right? Now if I take it basically, what can I do basically? So this b will go, this b will go. So if I try once again slowly. What can I do? Basically, is so q square b square by g p y1 plus b y1 square, basically by1, better let us say by1 into y1 by 2 plus is equal to, sorry, q square b square by g by2 plus by2 into y2 by 2, because this is how I am manipulating is very important that you need to understand actually, right? Now if I take it is this q square into b1b, I can cancel this and this, so q square by g, if I take it right into b is there here, then naturally if I do bring other side also, it is 1 by y1 minus 1 by y2, right, is equal to this. I will take it to other side, so it is what actually, if I take it other side, then it, if I take it b by 2, if I take common, then what will be there actually, if I take it y2 square minus y1 square, because this I take it on this side and this I brought it on this side. If you see that q square they like this, so now again bb will cancel, so q square by g into y2 minus y1 by y1 y2 is equal to, right, bb will be cancel already, this and this I cancel, so it is half into y2 plus y1 into y2 minus y1. Can we write like that? And so y2 minus y1 both sides, if I cancel it, q square by g into 1 by y1 y2 is equal to half into y2 plus y1. This is the thing. So a little bit again I will do it. Q square by g is equal to 1 by 2 into y1 y2 into y2 plus y1, right? Correct. So now if I do 2q square by g is equal to y1 y2 into y1 plus y2. So this is the equation of hydraulic jump for rectangular channels. You can ask what is the use of this equation, sir? The use of this equation is, suppose for example q will be given to you, one of the depths will be given to you, then you will be asked the other depth. So that means q and one depth of flow given, find the other depth of flow. So this is the question. So this is a common question in hydraulic jump. So kindly remember 2q square by g is equal to y1 y2 into y1 plus y2. This is enough actually as far as I am concerned. But actually now the people is, if you take this as a quadratic equation for example, then how to get the each depth also, that is also one of the questions that we can do it actually. Suppose that is a very simple thing. uh, for example, now what is the equation 2q square by g? Any manipulation is only starts with this equation. So if you remember this equation, all other equations, even if you don't remember also, using this equation, you can calculate. But I will show you one more equation basically. Now what I am going to derive is what is the equation for y1 or what is the equation for y2. This is what I am going to derive. So that is nothing very simple. I will do it also. Don't worry much. It is very simple actually. So if now I will take it, so it is 2q square by g, mathematical manipulation only, is equal to y1 plus y2, right? Now what I will do, multiply both sides, multiply both sides by y2. You can ask why y2, why not y1? Suppose you want whatever depth you want, you by that you, if you want equation for y2, multiply it by y2. If you want equation for y1, multiply by y1. That's all, simple equation. So 2q square into y2 divided by g y1 y2 is equal to the other side also, y2 into y1 plus y2. So what will happen? This y2 y2 will cancel. So 2q square by gy1, this is one term, is equal to y2 y1 plus y2 square. So now what I can write? It is y2 square plus y1 y2 minus 2q square by gy1 is equal to 0. So this is a quadratic equation. This is a quadratic equation. For any quadratic equation of ax square plus bx plus c is equal to 0, then you know what is x is equal to minus b plus or minus square root of b square minus 4ac by 2a. This is what generally we use. So the same principle I will use here. It is y2 square plus y1 y2, right, minus 2q square by gy1. So this is ax square plus bx basically plus c is equal to 0, right? So if you take it in this direction, so this is a quadratic equation in terms of y2. Right. So now if I to do it, actually what will happen? Y2 is equal to, for example, if I write it, y2 is equal to, now if I take it, what is the equation for me? Y2 is equal to minus, basically minus b means it is what is happening, it is minus y1, am I right? Plus or minus square root of b square y1 square minus 4, a is 1 into c is minus 2q square by gy1. This by 2 into a is 1. So this is the equation which I got. So it is nothing but minus y1 by 2, right? Now I will take one root first. So plus the second root I will write afterwards. So this 2 is now in the denominator, I will take it into the root. So it is y1 square by 4 minus, basically if it goes inside that 4, this 4 and 4 will cancel. So minus minus plus, it will be 2q square by gy1, right? This is what we got it. So therefore y2 is equal to, let's see what is happening actually. Answer is minus y1 by 2, right, plus square root of y1 square by 4 plus 2q square by gy1. This is one root. And if you want other root, basically it is equal to y2 is equal to minus y1 2 minus square root of y1 square by 4 plus 2q square by gy1. This is the other root. But remember that y2 will always be positive. Will always be positive. Therefore y2 is equal to minus y1 by 2 plus square root of y1 square by 4 plus 2q square by gy1. So this is another equation you can remember. So instead of multiplying it with y2, if you multiply with y1, so in the same way, if you can do it in the same way, we can write y1 is equal to minus y2 by 2 plus square root of y2 square by 4 plus 2q square by gy2. So this is also we can find out. So anything, so this is one, this is another thing. So this is how we can calculate the depths actually. If suppose somebody asks what is the relation between initial depth and sequent depth, this you can write it. But this equation is also you don't need to much worry, but fundamental equation is always for you. Kindly remember it is 2q square by g is equal to y1 y2 into y1 plus y2. As long as you remember this, any other equation you can do it. So this is the second one. What is the next one? Actually, the third one more is there. Derive basically, derive the expression, derive the expression for depth of hydraulic jump. All can be written in terms of upstream Froude number. So sometimes in the problem they will give you Froude number. So from the Froude number, how to do it also we can do it. That also, but anything is I am again and again repeating. The only equation that we have is only that. So till now, what are the equations that we have derived? It is 2q square by g is equal to y1 y2 into y1 plus y2. Then just now we know we have derived actually what we have derived. We know y2 is equal to basically what I have done minus y1 by 2 plus square root of y1 square by 4 plus 2q square by gy1. The moment you write here, it is all the remaining terms should be in terms of y1 only, or y1 is equal to minus y2 by 2 plus square root of y2 square by 4 plus 2q square by gy2. So this is the another thing. So these are the equations I have written. Now I want they want it to express in terms of Froude number. Remember, note that actually in case of hydraulic jump, the upstream Froude number is very important. The reason being the upstream is a supercritical flow. Downstream is subcritical flow. So upstream Froude number is very, very important. Nobody will talk about downstream for Froude number. So FR1 is important. FR2 is not important at all. The entire hydraulic jump characteristics depends on only FR1, not on FR2. Please remember, it is only the upstream Froude number that governs the entire hydraulic jump characteristics. So what is FR1? For rectangular channel, we are doing it. So naturally, it should be V1 by root G by 1, because the general equation for Froude number is V by root GD. But now when we are taking it rectangular channel, that hydraulic depth D becomes A by B, A by T. A by T is equal to By by B. B will cancel Y. So in the case of rectangular channels, that hydraulic depth is equal to depth of flow. So that's why I have written FR1 is equal to V1 by root GY1 for rectangular channels. Right? That is what you should remember. Or FR1 square is equal to V1 square by GY1. If you remember this, rest of the things I will show you. Now you take it any equation, one equation. For example, if you take y2 is equal to minus y1 by 2 plus square root of y1 square by 4 plus 2q square by gy1. If I take it that, then what is Q? Q is equal to what actually? It is Q by B. What is Q? Is basically, if I can write, Q is what actually? Area into velocity by B. Area means what actually? By into V divided by B. BB will cancel. So it is Vy. So therefore, we can write Q is equal to V1 Y1 or basically V2 Y2. This is first thing you should draw. So if you know this, actually now I will substitute the same thing in that. So how to substitute in that? Y2 is equal to minus Y1 by 2 plus square root of Y1 square by 4 plus 2Q. 2 into Q means what? V1 Y1 2Q square. So that means this is square by G into Y1 minus Y1 by 2 plus square root of Y1 square by 4. Plus if I do it this, what will happen? 2 V1 square Y1 square by GY1. Right. Next what I will do? Minus Y1 by 2. This I won't touch. Plus square root of y1 square by 4. What I will do is multiply by numerator and denominator by 4. 4 into 2v1 square y1 square by 4gy1. Only for some reason actually I will do. Y2 is equal to minus y1 by 2 plus square root of basically, right, y1 square by 4 plus 8 v1 square y1 square divided by 4g y1. Right? Now if I take common, because you're all manipulation only, y1 square by 4 if I take common, so what will be inside? Right? 1 plus 8v1 square by basically gy1. Am I right? Then still I will make a simplification. Y2 is equal to minus y1 by 2 plus square root of, right, y1 square by 4 into 8v1. So this what I will do is 1 second. So now y1 by 2 I will bring it outside, okay, because under from roots 2 by outside it is y1 by 2 into square root of 1 plus 8v1 square by gy1. This is what we have. So now what is Froude number FR1 we have written? FR1 is equal to V1 by square root of G by 1 or FR1 square is equal to V1 square by G by 1. So now if I substitute that in that, Y2 is equal to minus Y1 by 2 plus y1 by 2 into 1 plus, so right, v1 square by gy1 is 8fr1 square. So that is what is the answer I am interested. Y2 is equal to, now if I take common also basically whatever is possible, so y1 by 2 into square root of 1 plus 8fr1 square minus 1. So this is what I want to show. Somebody will ask you in terms of Froude number, you show it this. Remember, FR2 does not come into picture in case of hydraulic jump. So what is the conclusion of this particular lecture? What is the conclusion? The first one I have taken is the general equation for hydraulic jump is what actually? Q square by GA1 plus A1 Z1 bar is equal to Q square by GA2 plus A2 Z2 bar. Then second, what is the equation of hydraulic jump for rectangular channels? Is equal to 2q square by g is equal to y1 y2 into y1 plus y2. Then Third equation, what is y2 is equal to minus y1 by 2 plus square root of y1 square by 4 plus basically 2q square by gy. This is next. Then what is the fourth one? Y2 is equal to y1 by 2 into square root of 1 plus 8f for 1 square minus 1. So this is the conclusion of this chapter. Then what is y1? Initial depth. This is also called as pre-jump depth before formation of hydraulic jump. What is y2? Sequent depth. It is post-jump depth. Next. What is height of jump? Y2 minus y1. Right. Next. What is FR1? Proud number before jump. FR2 is proud number after jump. This is not important. This is what is important. But what is important is post jump depth is important, pre jump proud number is important. So this is the thing actually. And y1 and y2 are called what? Conjugate depths. What do you mean? What do you mean by conjugate depth? What do you mean by conjugate depth? Yet both the depths y1, y2, the specific force F is equal to Q square by GA plus AZ bar is constant. What is the depth of flow? At minimum specific force, critical depth. What problems will be given? Number one, given U, Y1, P, find Y2. This is one. Given U, Y2, P, find Y1. Given Y1, Y2, B, find Q. Given Proud number FR1, find, right? Initial depth, critical depth, and sequent depth. So these are some of the problems which we get in this case of the hydraulic jump. So these problems we should work it out actually to complete this topic. So before going to those problems, we have another topic called as energy losses in hydraulic jump. So that I will do first, and then we will take up problems straight away. So now in this lecture, it is only pure mathematical equations. First rectangular channel we have found out. But this topic today's lecture is so important from the angle that any problem in hydraulic jump you can solve with today's lecture equations. Fundamental equation is only 2q square by g plus 2q square by g is equal to y1 y2 into y1 plus y2. If you remember that, any other equation you can do in the exams also, absolutely no worry. But this you should remember. With this, I will stop this lecture at this place. And again, to the next lecture, we will take up energy loss.
Like, share, and subscribe. Hit the bell icon for more updates.